Я вижу, что люди еще рассаживаются.
Hi everyone, I see that people are coming to their seats. I still start with the dull things. I am Vladik Khononov. I was born in Belarus. For the last 24 years I've been living in Israel. I've been in programming for more than 20 years, in the last years as the architect. Architecture of distributed software is my hobby. I do it in the office and out of the office. I presented at a lot of architectural conferences like TVD Europe. I am member of the programming committee of Beaton London, and I work at a small project for Urari publishing house. Today I'm going to tell you about architecture from an unusual point of view, from the point of view of testing. Let's start with some story. 8 years ago, I worked, so to say, not at the very convenient project. Our company inherited a code base which had several owners. It was quite chaotic, and we had this kind of code. At a certain point of time, it was impossible to work with it. It was impossible to look at it because hundreds of classes, methods. After each release, the situation became only worse. At a certain point, I was lucky and I realized the dream of many programmers. An old acquaintance called me saying that he opens a startup and he invited me as an architect. It was not a greenfield project starting from scratch. I had an absolute freedom to choose an architectural solution. I agreed at once. My goal was to show the world how things should be done. And to prepare it, I wrote a lot of I read a lot of books. I read everything that was available, and I said that everything will be done right, correctly, clean code, modular architecture. A lot of efforts was spent on finding the ideal design which would enable us to add new features simply and easily. The codes should be simple and understandable, and of course everything, all functionality could be automatically tested. At the very beginning everything seemed to be all right, but time showed us that things were much more difficult than I expected. The more functionality we added, the more architectural changes it required. We had to change patterns, libraries, frameworks, and even change programming languages. And honestly, such changes were not positive from the viewpoint of my ego. I invested a lot in the ideal architecture, but it seemed to me it didn't pass the test of time. Today, 8 years later, my point of view has changed because during those years our business changed, the company learned on its own mistakes, the company adapted to changes in technology and business, the company was looking for additional sources of income, changed markets, spheres of activities, and we survived quite a number of technological revolutions in 8 times. Patterns, languages came and went, and whole infrastructures appeared and disappeared. Of course, all that was unpredictable. We made assumptions and made our stakes, And in case of a negative result, we changed our relations. And our system has been in production for more than 7 years. The developer team changed several times, and we even shifted development from Israel to other nations. Despite that, our code is not legacy yet. In spite of all the problems, that problem is a good shape. A good shape not because we had an ideal architecture from the very beginning. It was far from ideal. It was far from the state that it is in now. But the critical attitude to architecture and the architectural evolution helped us to keep our code base in the right tonus. In this presentation, I would like to share my opinion about the critical view of architecture, about testing it continuously, disclosing the weak points that require correction, doing it on time before the system collapses, and how to automate some architectural tests. But to begin with, I would like to give you some theory. Let's talk about software architecture, what it is, why does it require some time and effort. So, when we talk about architecture, we usually quote Rolf Johnson. Rolf Johnson said that architecture is an important stuff, whatever it is. Martin Fowler said that software architecture is all those decisions which are both important and hard to change. Both quotes says that architecture is important. Why? Because well-designed architecture is the main prerequisite of success. Architecture defines how well is the product, how well it could match functional and non-functional business requirements. Our software is part and parcel of modern business. The right design, the right architecture is business critical. And we say that software solves problems and eats up the world. But as Fowler said, these are not easy solutions. It's hard. In our company, we were thinking for a long time what kind of infrastructure to choose. Cloud, which was hype, or shall we use on-premise hardware? Databases, we had experience with Microsoft SQL Server, but we wanted to go to NoSQL. What kind of framework, what kind of pattern? Microservices, which were called SLA, or go a more conservative way. And of course, languages. We had great quarrels, similar to religious wars. Hard questions, as Mr. Fowler said, affecting our speed, our velocity, our satisfying business requirements. And business requirements were a special challenge. They changed all the time, and the system should be adaptable enough. On the other hand, those changes were absolutely unpredictable, and the architectural solutions became more and more complex and risky. One wrong step could ruin everything. Complexity of the system can increase exponentially. So the goal of architecture is to manage complexity. To reach the goal, we divide the system into several mutually related components or modules. They can look different: namespaces, services, microservices, subsystems. But whatever level they are in, when the system is divided into components, it's much easier to see mutual relations, mutual responsibilities, interactions. The system becomes simpler to assess and evaluate. Besides, modularization limits the scope of each architectural solution. One module can use LongDB as a database, the other can use MySQL. And if, due to a certain reason, you have to switch from MySQL to Postgres, the scope of change will be very limited. It will not cover the entire system. It will be related only to one little module. Thus, modular architecture divides the complexity into two types. The first type is local complexity, complexity of each particular module. And what is local complexity? How long should a newcomer spend, how much time he should spend to understand what happens on the screen? Yes. How long does it take for a novice to realize what is happening? For example, in our system we have a module to manage creative materials. Our designers put their different banners, different advertising materials. If a novice comes in, opens the module and sees, oh, all the classes, all the objects, they are related to the catalog of creative materials. Once we have a monolithic module with management of marketing campaigns and CRM for sales management, and then it required much more time to realize what is happening there. So marketing is one thing, all business values are there, but sales, it's different, everything was mixed, and it took time to find out what is where. A monolithic module was divided into two, one for advertising, the other for sales. As a result, we got two modules with much lower local complexity. But there is a compromise. If we reduce global complexity, if you split modules, we shall have one method per module, and then we shall kill the second type of complexity, that is global complexity. Global complexity reflects interoperation between the modules of the system. The lower it is, the easier it is to see the role of each module and understand it and change it if necessary. If, for instance, we have a low global complexity system, we have a few models, we have some interactions between them, and we can trace it here. Here it will take more time. So complexity is higher in this case. Components of this system are much closer linked to each other, and changing the interface in one component will affect the entire system, not only the module that has changed. Thus, division of a system into modules, the boundaries design is key for the architecture. So when answering the question what is an architecture, Ruth Mellon said that architecture is all about boundaries. what kind of elements will be inside the modules, which of them will be out of the module, which data will cross the boundaries, and what kind of compromise is or could be available, feasible. Of course, the definition is all right, but how can we fix the boundaries? And in the recent years, our industry tested 4 ways. The first one, at the waterfall times, we had the big design up front. We design all the systems up front, detailed design, before the programmers start working. Usually it was a wrong thing to do. This design wasn't flexible. It included a lot of assumption, and you have to guess on many occasions, and you found out that your assumption was wrong at a later stage, and if the design is big, so it could crash as one building. Then agile arrived. Agile means no design. Is that right? Let's raise new features, let's put them into production. At initial stages of development, it looks efficient, but sometime later, we see the after effect. The system became rigid, complex, and it is easier to rewrite it from scratch than to try to change it. Then everyone realized that no design is no way, and design became a responsibility of an architectural specialist, software architect. Each solution, each design becomes a matter of pride of the architect. If he planned something and the programmer said, this is wrong, you can improve it here. And of course, the first thing the architecture says that you are a fool, get out. All such changes are right. The people who design, the people who develop, the people who write codes can see they are right, but the architect is a boss. He resists changes, and he changed when it is too late or too expensive. And finally, quite recently, we saw evolutionary architecture. It's a new approach. It means that architecture should change incrementally while the system is evolving. The task is to adapt the system to continuously adapting business requirements and change it continuously, not just to change design, but to make it better, to make it more stable. As long as the system lives, as long as people work with it, the requirements are going to change and the design is going to change. Software architecture is confirmed by entropy. No matter how well we try to stabilize everything, but if we don't take care of that, everything declines into disorder and chaos. Not a single project starts from a team of programmers which come together, design everything, and say, yes, let's do this and that, and then they do it. Everyone tries to do their best for the product to be as good as possible, but the most difficult part of the design is not a greenfield project, but brownfield project. When some code is already in production, requirements change, you have to add new features. If you don't control architectural complexity, the system and the code base will gradually decline into disorder, and it will turn into a legacy code which no one will try to use. and they dream of eliminating it altogether and rewrite from scratch in a good way this time. At the same time, as Eric Evans says, legacy code requires respect because it's in production not just in vain. If people could eliminate it, they would have done it long ago. If it's in production, the company depends on it, and it brings benefits and profits and revenues to the company. To prevent declining, the system should be reshaped. We have to improve it, we have to make it better on time. The longer we wait, the longer we delay the change, the more we pay.
And here's the question. How do you determine the aspects of the architecture that need to be strengthened? And in order to answer this question, we need to be talking about the testing of architecture. Traditionally, we have two checks. Functional tests that test how accurately the implementation of the system follows the business requirements. Non-functional tests that check the parameters of the system itself, how scalable it is, how secure it is, how stress tolerant it is. And I believe that we have to use another type of test, an architectural test. Check for local and global complexity of the system. In other words, how the limits of the module and the system are in line with the business requirements. So when the lines or the limits of the system are clear, it's very easy to understand who does what. The coders need less time in order to be productive, to do their job, and the company overall becomes more effective, more efficient, and competitive. If the module limits are optimal, it's good, but when they are not clear, it's bad. And we know that there are even so-called anti-patterns when you have a big mess. If you go to Wikipedia, you can find this definition. A big bowl of mud is a haphazardly structured, sprawling, sloppy duct tape and baling wire spaghetti code jungle. These systems show unmistakable signs of unregulated growth and repeated expedient repair. Information is shared promiscuously among distant elements of the system, often to the point where nearly all the important information becomes global or duplicated. So again, you know what this whole thing is, and to determine whether or not the system has become a bowl of mud is very simple. The simplest heuristics for this is the vomiting. So if the code makes you nauseous, then this is a bowl of mud. It's what it is. If you see this kind of code, it's too late. The system has to be completely thrown away and rewritten from scratch. It's very easy. It's easier to spot a weakness in the architecture in the early stages. It's much better to fix a problem while it's small, before the system slides into some chaos. When the system shows signs of weakness, it becomes apparent. You just have to be attentive. You just have to watch out. And from the point of view of a coder, if it's not clear how to implement a new feature, when it's not clear what module this or that feature can be part of, it's one problem. Or when you need to add a feature and each new feature can be related to different modules at the same time. Another thing is when you have to change the function. This function in fact can cover different modules, or one change leads to unpredictable effects of things that pivotal changes in the completely unrelated things or unexpected things. In all of these cases, we're dealing with the global complexity of the system. In other words, modules are very closely related to each other, and changing in one module affects the system overall. So, when the global difficulty or when the complexity is too high, you can't use unit tests on the system. Units are literally smeared between different modules, and how do you use unit testing on such a system? Michael Feathers wrote a tweet. He said, "Unit tests test units." In other words, how well the system is structured and kind of split into modules. And this really is relevant to my experience when people say with pride that they only do end-to-end tests and they don't use any unit tests because they're fragile, they fail, you have to rewrite them. But the problem is not with unit tests, but with the system itself. From the point of view of testers, it's very difficult when the business logic changes, the programmers deploy changes for, let's say, for tests. But it turns out that in some part of the system, previous logic is still relevant. It's still kind of used, and sometimes it turns out that the coders just didn't know that the logic had to change throughout the code, throughout the architecture, and too high complexity in certain parts of the system can manifest itself in failures of regression tests. For example, coders deploy a new feature and you have to run regression tests throughout the entire system because nobody knows how these changes, how these new features affect the entire system. Because the coders originally have a hard time determining how this new feature affects the system overall, because everything is connected to everything. So this module can be and need to be kind of compartmentalized into compartments that are loosely or unconnected at all. So administrators have to watch out for such situations. So, for example, in our system, we had a system for management ad campaigns and a system for sales management. And both these systems work with the entity called lead. For example, somebody is interested in a product, it's not yet a deal, but it's a lead. Let's say, for example, these systems are implemented as normal microservices. Each of them has their own dedicated database, and they interact through some API. So when you install the system at a certain point of time, in each of these databases, we will have the same lead, Vasya, let's say by the name of Vasya, and her phone number may be different. And we don't know which is which. The timestamps are unpredictable. They are very hard to track. On the other hand, a user operation may affect several modules at the same time. It can't guarantee the synchronization of these changes. For example, if we get information about a lead and the same transaction, for example, a lead, or you try to open up a new card, open up a new kind of entry for a lead, assign the person or an associate that's responsible for a lead, it becomes completely hard to navigate. So in this case, a local complexity of all these modules is underestimated, and we pay a very high price in the form of increased complexity of the system, overall complexity of the system. So if we And by the way, the problem of incorrectly set boundaries can affect sysadmins. And I'm talking about sysadmins, not DevOps, because DevOps is not a profession; it's a culture. So a lack of DevOps culture, in fact, smacks of something wrong, something badly wrong with the whole project. There may be some increased complexity in certain modules. For example, there may be 200 services that talk to each other, and that's an example of increased global complexity. And bad boundaries, everybody suffers. That's the formula. It's very hard to keep track of everything because, for example, sysadmins, they don't have to implement new features. And in order to make sure that the architecture of a system does not rot from the inside out, it has to be improved. In order to know how to improve it, you need to get feedback from everybody involved in the system. You need to always take a hard look at the design. You have to always test the system. There's bad news, there's good news. Well, the bad news is that not everything is simple, but the good news is automation will come to the rescue. There are static code analysis methods. They analyze the code base, they query the code's health. These systems are multiple for different programming languages, for multiple platforms. We had, I think we had someone from PwC Studio, and they support Java, C++, C#. For an example, I'm going to use NDPen. Well, I think this is an illustrative example for independent. This is a very good example that kind of generalizes to all other programming languages. You analyze the code, you upload the code, it performs various analyses, measures the complexity of the code, delivers other metrics. But the main drawbacks of this instrument is that when you launch it for the first time, it's extremely scary. So what you do is you feed it some code, and out you get this scary picture, which has hundreds of quality checks. Some of them are red, and you are immediately stressed because it seems like the code is trashed and it's worth nothing, has to be completely discarded. And of course, in order to be able to use this instrument, in order to do justice to this instrument, you have to read the documentation. All the checks that the instrument performs were created for a reason. You have to understand them. Which of them are relevant, which of them are less relevant to your project. You're not limited by the built-in checks. You can write your own ones, you write your own procedures. So as a result, we get this nice diagram. Now, if we look at it as a diagram of the entire system at the global level, we see that the complexity is pretty high. All of these elements are tightly linked. They reference each other, and this graph reflects what happens inside a specific module. Here we see a very good example of high level of local complexity. Here in this part, things are kind of packed together and they can be easily separated from the rest of the module. Here we have two function calls. So, if you look at this diagram, if you just inspect it visually, you can get an idea what can be improved here. You can decrease the complexity of this local module without increasing the global complexity. You can just add an additional module which will be very loosely connected to the rest of the system components. The weak point is checking the connectivity between the services, because they are very often implemented as separate projects. They may even be written in different programming languages and for different platforms. You can bypass it if you monitor their public APIs, these services. If you look at how many public methods each service have, or for example, the notifications that a service receives from other services. And remember, there's no magic about these values. There are no benchmarks, like it's good when you are below 10, or it's bad if you're above 10. You need to look at the trends. If the boundaries of these methods begin to get blurred, then it's probably not a good sign. It's a sign of increasing entropy. For example, we had a service for ad campaigns. If the API, I don't remember, let's say, if the API had, well, let's say there were 10 methods in the API, and we decided at a certain point that we needed to open up a new service. We would put all the things related to billing, for example, into that new service. Now, if you look at this service, take a step back and look at this service, you see that the number of its APIs doubled. And this significant increase suggests that the business probably hadn't changed. The business side probably hadn't changed, but the local complexity increased. Also, Depend can be integrated into a CI pipeline, which would enable it to build these graphs for each build and to track the code base throughout the entire lifecycle of the project. Well, that's it. That concludes my presentation. So, in summary, software architecture manages complexity. We compartmentalized our system into modules, local and global complexities. From poorly defined module boundaries, we get lots of problems that affect everybody, and we have to watch out for when these boundaries become blurred. We can use a statistical analysis of the static analysis of the code to control code-based evolution. If you're interested in the topic of evolution of the code architecture, take a look at this book. It's better read in the original, not in Russian. And I encourage you to take a look at the presentation of the author of this book, Neil Ford. Speaking about books, Domain-Driven Design book was published recently. I contributed a chapter to this book which describes many of the points that I have tackled, that I have addressed today. I explained my story in terms of domain-driven design. You can download this book free of charge, but if you want to support the authors, you can do so, and all the money will go to a charity. And if I didn't completely bore you, please go to my social media. You can go to my Twitter or to my website. Let's take a look if there are any questions. Yeah, we have questions.
Tour of production.
How often can we catch architectural errors in production? Well, if you have errors in production, then something is really wrong. For example, well, what kind of errors are we talking about? Database errors, database corruption, or data can become a duplicate. They can be duplicated across modules, and you can't compare them. You can't deduplicate them. And as a rule, these problems can be identified in production, in development, in QA, in automated tests. Usually things are perfect. And if you ever identify these problems, you usually identify them in production, late at night. In evaluation architecture, it's difficult to design automatic tests. How do we do without automation? Good question. The question is, what tests do you emphasize? Well, tests can be adapted as the boundaries of your modules change if the system is tested using end-to-end tests, then these tests are quite fragile, and every time you change your architecture, you have to rewrite everything. So speaking generally, there is the pyramid of tests. Unit is at the base of this pyramid, and integration tests, and end-to-end is at the top. So the question is a little bit controversial, and I discussed this at a different presentation at this same conference. But last year, well, some business applications are better tested using unit tests. Others are better tested using end-to-end tests and integration tests. It really depends on the kind of the project. You mentioned functional and non-functional testing, but you have not talked about change testing. Shouldn't be identified as a separate type of test? Well, I believe that functional testing is exactly the kind of testing that is related to changing. When the business logic of an application changes, for example, yesterday we had an interesting presentation about change testing, testing the changes on the level of contracts, the level of APIs. I don't know what kind of testing that is. I believe it's more functional testing, but that's just my opinion. And it was the last question. Are there any questions from the audience? 1, 2, 3, no questions. All right.